video will cover the lesson even on Friday, January 15th. The video was recording during fourth period. So the lesson is about synthetic division, which is a better way to divide polynomials. And then after that, we'll move on to the remainder theorem. And remember how I told you the remainder is so important that it actually has its own theorem after the remainder. Okay, so we'll get to that in a minute. Before we start synthetic division, let's just do a very quick review of what was happening here with the division, the long division. And so again, we start with dividing the 2x cubed by x. 2x cubed divided by x, and of course we got 2x squared, right? And so that was here, part of the quotient. Then we multiply 2x squared times x, we get 2x cubed. 2x squared times negative 3 is negative 6x squared. And then one thing that they're not doing here, however, I want to make emphasis on is you change the signs because you're actually subtracting. So that's how those two cancel out. And here we have positive 6x minus x squared, so that will be positive 5x squared. And then the next step for us is to divide the 5x squared divided by x. And with that, we get 5x. Remember, we are subtracting the exponents of the variables, right? So that 5x now is part of the quotient. And after that, we need to multiply 5x times x, and that's how they got here, 5x squared. Then we multiply 5x times negative 3, and we get negative 15x. After that, we need to subtract. So, of course, we change the signs. We don't see it here, but I'm going to add those signs there. That's how we get rid of the x squared terms because they're opposite, so they make up a 0. And then here we have positive 15x minus 13x, and that gives me positive 2x. And the very last step is to divide positive 2x divided by x, and so that will give me a 2. Now from here, the 2 goes up here, part of the quotient, and then of course we multiply, so 2 times x, we get 2x, 2 times negative 3, we get negative 6. Last thing to do is to subtract, so we must change the signs. That cancels out to 0, and here we have 1 plus 6, which is 7. So the remainder is 7, equal to 7. Yes?
So you just change the signs when you subtract. Is that because you're like
because I'm subtracting
them times negative 1 or something?
Where? Which number?
Because you said you change the signs when you subtract. I guess I'm asking why. Why are you changing the signs when you subtract?
Oh yeah, because we are multiplying, but it's kind of like we're adding the opposite. So since we're adding the opposite, we have to change the sign. So addition is subtraction is the same as addition, but with negative numbers. So anytime, let's say you want to say 5x, and you have 4x positive, but you want to subtract 4x, then you have to change it to a negative. But if I had, let's say, 5x, and then I have negative 4x, and I want to subtract negative 4x, this negative is going to change my operation to be something like 5x plus 4x, because the sign will change to the opposite sign. Always. All right, so what we have here on the right side, guys, is the same thing, but the difference is that they do not have any type of variables. Do you guys notice? They're just numbers. And so with these numbers here, they get the same remainder. And actually, if you look at the coefficients, which are here with, in red, of the quotient, you have the same numbers, right? 2, 5, and 2, 2, 5, and 2. So that is the idea of synthetic division, that we're going to eliminate those variables so that we can divide easier and quicker, okay? And so let's get started. Now, the idea here is that the divisor, well, let's define our terms. The polynomial here is the dividend, and the binomial here is the divisor. So if I take the divisor, x minus 3, and I equal it to 0, and then I want to solve for x, so we need to add 3, right, to both sides. Or we may say we take this negative 3 across, and that turns into positive 3. So what we're going to do, and this is called synthetic division, all right? We're going to have this little box here, and inside that little box, we're going to write the number 3. Now, what I want us to write next to the box are the coefficients of the dividend. So we start here, the coefficient of x cubed is a 2. The coefficient of x squared is a negative 1. We still need to keep the signs. The coefficient of x is a negative 13. And the constant term happens to be a positive 1. Yes, you guys ready? Yeah, so first, we're going to drop the first term. And then we're going to multiply negative 3 times 2, and then we're going to write it here. And so that is going to be 6. And then we're going to add these terms here. So negative 1 plus 6 is positive 5. Now, why are we adding and not subtracting? What do you guys think? It's the opposite. And what can you tell me about the number that we have inside that tiny little box and the constant term of the divisor? This is the divisor. Which one is the constant term? Not positive 3, negative 3. Right? The constant term is negative 3. So if you notice, the number that I have here inside the box is actually the opposite of the constant term. So you always do that. And so with us doing that, that takes care of the subtraction process. So we don't need to subtract anymore. There's no need for us to change the signs because we already have this number here, which is the opposite of the constant in the divisor. All right? That's why we only add. All we do is multiply, add, multiply, add, multiply, add. So let's try it again. So now we're going to multiply the same 3 times 5, and it goes here. And so that is equal to 15, positive. And then we add negative 13 plus 15, and that is going to give me a 2. And then lastly, we take 3 multiplied by 2, write it down here, and that is 6. And then we add again, 1 plus 6, and that is equal to 7. So this 7 here is actually the remainder, which happened to be the same remainder here. And if you guys notice, it's actually the same problem from the beginning, the one that we did with long division. So the problem that you see here, the one that I went over, is the same here, but done with synthetic division. Let's look at the variables. And so we have the following variables. We have the dividend started with x to what power? No, not 2, 3 or 2. So here, this is x cubed, this is x squared, this is x, and this is a constant term, the 1. After we divided, what was the degree of the divisor? What is the exponent of the x here? A 1. So the degree of the divisor is a 1. So in general, if you take something of degree 3 and you divide it by something of degree 1, what do you get? Something of degree what? 2. So the idea is that here, the new numbers that you obtain will represent x squared, so it will be 1 degree less than the dividend. This will be x. This will be the constant term, and this is the remainder, like we already established. All right? Okay, so let's move on to the next example, example 2. And so we're going to do synthetic division again. This one right here is the dividend. So we're going to need all of the coefficients that come from it. All right? And our divisor is x plus 2. So the number that we need to have inside the box is not going to be plus 2. It's actually going to be the opposite of positive 2, which is negative 2. And the coefficients, remember, even if you don't see a number with a term, it's still a 1, right? We have 1 x to the 4th. The coefficient of x cubed is a negative 2, and then negative 11, and then positive 5, and then positive 34. One thing to consider here is very important, so please write this down. Terms must be in descending order, meaning from small, I'm sorry, not small, from the largest to smallest with respect to the degree. If they are not in that order, you have to reorder them before you do synthetic division. So to start the process, do you guys remember what was the first step? Before we multiply? We just drop the first number, that's it. So 1. Then we multiply. So negative 2 times 1 is negative 2. And then we add. Negative 2 plus negative 2 is? Negative 4. Then we multiply. Negative 2 times negative 4 is positive 8. And then we add. Negative 11 plus 8 is negative 3. Then we multiply. Negative 2 times negative 3, that will be positive 6. Then we add 5 plus 6, 11. And then we multiply again. Negative 2 times 11, and that is negative 22. And then we add. So 34 plus negative 22, and that's 12. Thank you very much. And so that right there will be the remainder. So let's trace our steps. We started with what was the degree of the dividend? Of this big polynomial here. What's the highest exponent there?
4.
4. So that was something of degree 4. So after dividing by a divisor of degree 1, the resultant coefficients are representing something of degree 3, degree 2, degree 1, and the constant term. Okay. So what this means is that we could rewrite our polynomial, and I believe you're going to have to do some of this for your homework. And let's say we have x to the 4th power minus 2x to the 3rd power minus 11x squared plus 5x plus 34. Oops, I hope it fits. Divided by x plus 2. It will be equal to the quotient, which is here. X cubed minus 4x squared minus 3x plus 11. And then we still need to add the remainder, which is 12. But not only 12, 12 divided by x plus 2. This one goes here, okay? I just ran out of space. All right, now, I want you guys to practice that one. We're running short on time, so I'm going to be working the problem out as you work. Try to do it on your own and then check with Mike, okay? Thank you. Tomorrow, first step is to drop the first number, okay? Okay, so drop the first term. -3 times 1 is -3. I get a 0. -3 times 0 is 0. Okay, so you should have something like that. If I made a mistake, please let me know, okay? Do we agree with the answer? Oh, I'm gonna rewrite it as in polynomial form. So let's see. Here we have we start with something of degree 4, so we're going to obtain something of degree 3, correct? So then those coefficients represent x cubed, x squared, x, and the number, and this is the remainder. Okay, so just like we would in a fraction, let's say 37 divided by 5, you will write it as 5 goes 7 times into 37, but then we still have 2/5. So that's what I'm going to do here, okay? So the answer will be 1x cubed, no x squared because that coefficient is 0, and then minus 5x plus 21, and then minus 51 as the remainder, but we still need to write it with the divisor under as a fraction. Okay, I'm going to go to the next slide, guys.
Are you still recording?
Yes. Okay, now what we're going to do here, before we check into this remainder theorem, I want you to do the following. We're going to find P of 2 by substitution. So this is like finding f of 2 if the name of the function was f. In this case, we're talking about a polynomial, so it is common to use capital P. So we're going to take this polynomial here and find P of 2. So that means that we're going to substitute a 2 for every x. In this case, we will get, first we need to take care of the exponents, so 2 cubed is 8, 2 squared is 4, and now we take care of the multiplication, so that will be 2 times 8 is 16, negative 4 times 4 is negative 16, and then we have a plus 5 here. 16 and negative 16 are opposite, so they cancel, equals 0, so our answer is 5. So what we have here is that P of 2 is equal to 5, and what will that mean as a table of values will be that if x is equal to 2, y is equal to 5. That's what it means, right? We're finding the function value by substitution. Substitution. For part B, they're asking us to use the remainder theorem to find to divide by x minus 2. However, we know that in the little box, we're not going to use the -2, right? What number are we going to use instead? +2. So let's do this quickly. And the coefficients here are going to be 2, -4. And I want you to notice something. There is no x value here, or no x term. You guys notice we go from x squared to the constant? So because of that, we must account with a 0 for that space. We need to keep that space. And then we have the constant term. So we drop the first number, then we multiply. 2 times 2 is +4. -4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. So 5 plus 0 is 5. And that is the remainder, right? Now, do you guys notice how the remainder happens to be the same as this number, the function value? Yes? So that is actually the remainder theorem. Now, whenever you're looking for a function value, you could perform synthetic division with that same number. In this case, it was a 2. And so when you do that, then the remainder will be the same as the function value for that function. Yes, then.
Where do you get the 0?
Well, -4 plus 4 is 0. 2 times 0 is 0. Oh, this 0.
Not 0.
This 0 is coming from the fact that we don't have an x. We have 0x. So we have to keep the space for it. Okay. And I know it's time to go, but since you guys didn't watch the video, I'm going to go ahead and go over this problem. Okay? So we're finding the function value of 4. That's the number that goes inside the box, period. We don't need to change. If they give it to us as like that, we leave it like that. We don't change it to the opposite sign. Now, coefficients. We have x to the 6th power, that's a 4. X to the 5th power, that's a -25. X to the 4th power, that's a +35. Do we have an x cubed? No. So we need to put a 0 there. All right? Now, do we have an x squared? Yes, 17. However, you need to include the x cubed 0 before the x squared. Do we have an x term? No. We still need to put a 0. Do we have a constant term? No. We still have to put a 0. If you don't do that, then your division will not be correct. So let's do this together quickly. We drop the first term, then we multiply. 4 times 4 is 16. -25 plus 16 is -9. 4 times -9 is -36. 35 minus 36 is -1. What do we do next? Multiply. So 4 times -1 is? Negative. 0 minus 4 is? Then we multiply. 4 times -4 is? Okay, 17 plus -16 is? 1. And then we multiply. 4 times 1 is? 4. 0 plus 4 is? 4. And then? Multiply. 4 times 4, 16. 0 plus 16, 16. So what this means is that the function value at x equals 4 is 16. Okay? And that's the end of the video.